All right, so today we're diving into a paper called SWE Bench plus Leave, Enhanced Coding Benchmark for LLMs. And, well, this is all about...
LLMs.
Yeah, LLMs and how well they can fix code. But, spoiler alert, it finds some pretty big problems with the benchmarks we use to evaluate these models.
Yeah, this is a big deal.
Basically, it found that some LLMs were passing these tests, not by actually like solving the problems, but by kind of like exploiting loopholes in the tests themselves.
Yeah, it's almost like they're figuring out how to game the system instead of actually showing us they have good coding skills.
Right, like it's more about finding the shortcuts than actually like understanding and fixing the code. And the researchers who wrote this paper,
They dug into a popular benchmark called SWE Bench.
and they found two major flaws that were messing up the result.
Yeah, the first one is this thing they call solution leakage.
Okay, solution leakage.
Yeah, so imagine you're taking a math test and you just copy the answers from the back of the book.
Okay, I see where you're going with this.
That's basically what some of these LLMs were doing. Yeah, they found that in a lot of cases, the solution to the coding problem was actually like right there in the issue report itself.
So they didn't even have to solve the problem. They just had to like extract the answer.
Exactly. And they found a really clear example of this in the Simpy project.
Oh yeah, I remember reading about that.
Yeah, it was issue report number 16669.
16669.
Yep. And the solution code was just sitting right there in the issue description.
No wonder the LLM aced it.
Right.
So solution leakage, big problem. But they also found another issue, right? Something about the test cases.
Yes, weak test cases. And this is a huge problem too.
In what way?
Well, they found that a bunch of the code fixes that were marked as successful.
You mean they passed the tests?
Yeah, they passed the test, but they weren't actually correct or complete solutions.
So they were passing, but not because they actually like fixed the issue.
Exactly. The tests were just way too easy. It's like giving someone a driving test where all they have to do is drive in a straight line for 5 seconds.
They might pass, but it doesn't mean they can actually drive.
Right, and they actually found a case in the Matplotlib project where the LLM changed the code in completely the wrong file.
Oh, wow.
And it still passed the test because they weren't good enough to catch that kind of mistake.
So we've got these two big problems, solution leakage and weak test cases. So what did the researchers actually do about this?
Well, they didn't just complain about the problems.
Thank goodness.
They went ahead and made a brand new improved benchmark called SWE BenchPlus.
SWEBenchPlus. Okay, so what makes this one different?
First, they tackled that solution leakage problem head on.
How?
They made sure that none of the issues in the new dataset included the solution in the description.
So no more easy answers for the LLMs to just copy and paste?
No, and for the weak test cases, they did something really clever.
Okay, I'm intrigued.
They used issues that were created after the cutoff date for the data that LLMs were trained on.
You mean like they used brand new issues that the LLMs had never seen before?
Exactly.
So it's like making sure students haven't seen the exam questions before the test.
Yeah, that's a good way to put it. It forces the LLMs to really think on their feet and actually solve the problem.
I like it. So new benchmark, fresh data, no cheating allowed. Sounds like a much fairer fight. And did they actually test this new benchmark on some of the, the state-of-the-art LLMs?
Oh yeah, they tested it on 4 really powerful models. SWERAG with GPT 3.5, SWERAG with GPT-4, SWE Agent with GPT-4, and then AutoCode Rover with GPT-4.
Wow, that's a pretty impressive lineup.
It is, and here's where things get really interesting. Every single model did way worse on SWE Bench Plus than on the original SWE Bench.
Wait, so they were all much less successful on the tougher benchmark?
The numbers are pretty shocking, actually.
Lay it on me.
Okay, so SWERAG with GPT 3.5 only had a resolution rate of 0.55%.
Wow, that's way lower than I would have expected.
I know, right? And then SWERAG with GPT-4 did a little better at 0.73%, but still really low.
What about the other two?
SWE Agent with GPT-4 was also at 0.55%.
Okay, and AutoCode Rover.
That one did the best, but it was only 3.83%.
So way lower than you would think.
Yeah, exactly. And it just shows you how important these benchmarks really are.
Yeah, we can't just trust those like flashy performance claims. We need these tough, well-designed tests to actually see what these LLMs can do.
And that's exactly what SWE Bench Plus is trying to do.
So even though SWE Bench Plus is definitely a step in the right direction, you mentioned earlier that weak test cases are still a problem.
Yeah, it's still something we need to work on.
Just how big of a problem are we talking about here?
Well, they found that over 2/3 of the solutions that were marked as resolved.
Meaning they passed the test.
Right, they passed the test, but they didn't actually fix the issue correctly.
2/3. That's a pretty scary number.
It is, and it shows how much more work we need to do to develop better tests.
Okay, so It seems like we have a long way to go before we can really accurately assess the capabilities of these AI assistants.
I think that's fair to say, and it's all part of the research process,
Huh.
constantly pushing the boundaries of what we know and coming up with better ways to evaluate these really complex systems.
And it's not just about accuracy, right? There's also the question of cost and time efficiency, especially when you're thinking about real-world applications.
Yeah, that's what the researchers call effectiveness-aware evaluation. And it's super important because in the real world, it doesn't just matter if an LLM can fix code, it matters how long it takes and how much it costs.
Makes sense. Nobody wants to wait forever or pay a fortune just to fix a simple bug.
Exactly. And one of the things they found was that SWE agent with GPT-4, even though it performed about the same as RAD plus GPT-4, it was a lot more expensive to run.
So you might be paying more for a model that doesn't actually give you much better results.
Exactly. And that's something developers and researchers definitely need to think about.
Well, I think this has been a great overview of the paper so far. Before we move on to the next part, let's quickly summarize the key points for our listeners.
Yeah, so the main takeaway is that we really need accurate and rigorous benchmarks if we want to evaluate AI-powered code repair. The original SWE Bench was a good start, but it had some big problems like solution leakage and those weak test cases.
And that's where SWEBenchPlus comes in. It gets rid of the solution leakage and uses fresh issues that the LLMs haven't seen before.
But with those weak test cases are still a problem, and that means we need more research to develop even better testing methods.
We can't just assume that these LLMs are as good as everyone says they are.
And the last point is that it's not just about accuracy. We also need to think about how much these models cost and how long they take to run.
Practical considerations are key if we want people to actually use them in the real world.
Exactly.
All right, so that wraps up part 1 of our deep dive. We'll be back in just a minute for part 2, where we'll dig into what all of this means and explore what the future might hold for AI-powered code repair. Okay, so we're back, and we've been talking about this whole SW Bench thing and how the researchers create this new and improved version. But I think it's worth taking a step back for a second.
Right.
Like, why does all this even matter? Why should our listeners care about whether or not we have good benchmarks for AI code repair? What's the big picture here?
You're right. That's a great point. This isn't just about like academic metrics or something.
Right.
This is about the future of software development, like how we're actually going to build software in the future.
Okay, I'm listening.
We're on the edge of this huge shift with LLMs potentially being able to automate all these tasks that take human developers forever.
Yeah, I can see that. Like, imagine LLMs finding and fixing bugs.
Right, or like generating code from just like a description.
Or refactoring code to make it more efficient.
Even like catching security vulnerabilities before they become a problem. I mean, it's pretty mind-blowing when you think about it.
It is, but here's the thing, right? To really unlock that potential, we need to be able to trust these LLMs.
And how do we build trust?
By knowing they can actually do what we're asking them to do. And that's where these benchmarks come in.
Right, they're like the foundation for everything else.
Exactly. So this isn't just about measuring progress for the sake of it. It's about making sure we're developing and using these AI tools responsibly.
If we just rush to use LLMs everywhere without really knowing how good they are,
What could happen?
we could end up introducing more bugs into our software, which could have huge consequences.
Yeah, think about like the apps we use every day or
Yeah.
even critical infrastructure.
Exactly. The stakes are really high. So this paper is kind of a wake-up call for everyone in the field to really focus on better benchmarks.
It's like saying, hey, we need to get this right.
And it raises this question of like, okay, where do we go from here? How do we make these benchmarks even better?
Yeah. What are some of the next steps?
I think one of the most exciting areas is in developing these like smarter, more dynamic tests.
Yeah. What do you mean by dynamic?
So instead of just having these like static tests that are the same for every LLM,
Right.
imagine tests that actually adapt to the specific code being evaluated. So they're always pushing the LLM to its limits.
Oh, that's interesting. Like a personalized test for each LLM.
Exactly. And it's not just about making the tests harder. It's also about making sure they're fair.
What do you mean by fair?
Well, we need to make sure that the benchmarks aren't accidentally favoring certain types of LLMs or coding styles.
So it's like creating a level playing field where everyone is being judged by the same standards.
Exactly. And then there's also the question of robustness.
Robustness.
Yeah, like making sure the LLMs can't cheat the system or find loopholes in the tests.
We need to make sure they're actually solving the problems, not just gaming the system.
Right. So we're looking for benchmarks that are tough, fair, and efficient.
That's quite a challenge.
It is, but it's a challenge we need to meet if we want to really see what AI can do for software development.
Okay, so we've talked about the benchmarks themselves, but let's go back to those really low resolution rates we saw on SWE BenchPlus.
Yeah, those are pretty surprising.
Why are even the most advanced LLMs still struggling with these code repair tasks? Like, what are some of the fundamental limitations we're seeing here?
That's a good question, and honestly, it's a question that a lot of researchers are trying to answer right now. LLMs have come a long way.
Yeah, they can do some pretty amazing things.
But they still have trouble with certain things, like really understanding code and being able to reason about it.
Can you give us some specific examples?
One of the biggest challenges is dealing with ambiguity in human language.
Ambiguity, like what do you mean?
Like, think about how we use slang or idioms or just imply things without saying them directly.
Oh, yeah. That could be hard for humans to understand sometimes, let alone an AI.
Right, so even if an LLM can understand the individual words in a code comment, it might not understand what the developer was actually trying to say.
And that intent is really important when you're trying to fix a bug.
Exactly. Context is key in code repair.
And beyond context, there's also the issue of like complex logic and reasoning.
Sometimes LLMs make changes that seem illogical to us humans, even if they found the error. It's like they're missing the bigger picture of how the code all fits together.
So it's not just about finding the bug, it's about understanding how that bug affects everything else.
Exactly, and that's a really hard problem to solve, even for experienced human developers.
So maybe those low resolution rates shouldn't be too surprising. After all, we're asking these LLMs to do something that's incredibly difficult.
I think that's a fair point. We need to be realistic about our expectations.
But how do we actually bridge that gap? How do we help LLMs get better at code repair? What are some of the things researchers are working on?
Well, one approach is to develop LLMs that are specifically trained for code repair.
So instead of having a general purpose LLM that can do a bunch of different things.
We create one that's like an expert in debugging and fixing code.
Okay, so they become specialists instead of generalists.
Exactly, and that kind of specialized training could lead to much better results. Another interesting area is in developing hybrid systems.
Hybrid systems, what are those?
So instead of just using an LLM by itself, you combine it with more traditional code analysis techniques.
So it's like a team effort. The LLM and the traditional tools each bring their own strengths to the table.
Right. Like, for example, the LLM could come up with a bunch of potential fixes, and then a separate tool could analyze those fixes and pick the best one.
That makes sense. You're combining the best of both worlds. And of course, we can't forget about human feedback.
That's super important. Developers can help the LLMs learn by telling them which fixes are good and which ones are bad.
And by explaining why they made certain decisions or how the code is supposed to work.
Right. It's all about creating this feedback loop that helps the LLMs get better over time.
So it seems like we're in this really interesting period where software development is changing really rapidly.
Yeah, there's so much potential, but also a lot of challenges. We need to be careful and think about the consequences of what we're building.
We've seen what can happen when we just trust AI blindly.
Exactly. So we need to keep testing and evaluating these systems, and we need to have open and honest conversations about the ethical implications of all of this.
It's about finding that balance, right? Embracing the potential of AI, but also being aware of the risks.
You got it. And this paper is a good reminder of that it's pushing the field to be more rigorous and to really think critically about how we're evaluating these systems.
So as we move towards this future where LLMs are being used more and more in software development, what are some things that developers should keep in mind?
I would say, first of all, don't just blindly trust the AI. Always double check the code that it generates and make sure it actually works.
So treat it as a suggestion, not a final answer.
Exactly. And second, be aware of the potential biases that these LLMs might have.
Because they're trained on massive data sets of code that might contain all sorts of biases.
Right. So the LLM might not always produce the most efficient solution, or it might accidentally introduce biases into the code.
Okay, that's something to be aware of. And what's the third thing?
Be part of the conversation, engage with the research community, give feedback on the tools you're using, and help shape the future of this technology.
Yeah, developers have a lot of experience and insights that can be really valuable to researchers.
Exactly.
All right, so I think that's a good wrap up for this part of our deep dive. We've talked about the importance of benchmarks, the potential and pitfalls of LLMs, and some of the ways we can make these systems better.
Yeah, it's been a great discussion.
And in the final part, we'll take a look at the big picture and think about what all of this means for the future of software development. Okay, so we're back for the final part of our deep dive. And we've talked about the benchmarks and the challenges of evaluating these LLMs. But now I want to zoom out a little bit.
Zoom out.
Yeah, what does all this mean for the big picture? What does the future hold for AI-powered code repair.
Hmm.
Are we going to see like a total revolution in software development?
Yes. The million-dollar question, are we all going to be replaced by robots?
Well, not robots exactly, but AI programmers, right? I mean, is that where this is all headed?
I don't think we need to panic just yet. I don't think we're all going to be out of a job tomorrow.
Yeah, that's a relief.
Yeah.
But seriously, how do you see this technology evolving?
I think it's pretty clear that LLMs are going to change how we write software in a big way, even if they don't completely replace human developers.
So it's less about replacement and more about like transformation.
Exactly. LLMs are going to become like these super powerful tools that help us do our jobs better and faster.
Like imagine all the time we could save if LLMs could handle all those tedious tasks that we all hate doing.
Right, like debugging or refactoring or even just writing boilerplate code.
That would free up so much time and energy for us to focus on the more creative parts of software development.
Exactly. We could spend more time designing elegant solutions and less time wrestling with bugs.
I like the sound of that. And it's not just about saving time, right?
No, LLMs could also help us write better code in the first place by catching errors and vulnerabilities early on.
It's like having an AI pair programmer looking over your shoulder and giving you feedback.
That's a great analogy, and this could be especially helpful for new developers who are still learning the ropes.
Yeah, it could make software development more accessible to more people, which would be amazing.
It would, but we also need to be realistic about the potential downsides. We've already talked about how these technologies are still pretty new, and we need to be careful about how we use them.
We've seen what can happen when we put too much trust in AI without really understanding how it works.
Right, so we need to keep doing rigorous testing and evaluation, and we need to have honest conversations about the ethical implications of all this.
It's about finding that balance, isn't it? Embracing the power of AI, but also being mindful of the risks.
That's exactly right. And this paper we've been talking about is a great example of that. It's pushing us to think critically about how we evaluate these systems and to make sure we're doing it responsibly.
Okay, so if you had to sum up the key takeaway from all of this, what would it be?
I would say the future of AI-powered code repair is really exciting, but it's up to all of us to make sure the future is a good one. We need to demand good science, good engineering, and we need to be thoughtful about the ethical implications of these technologies.
That's a great message to end on. Thanks so much for joining me for this deep dive. It's been a really thought-provoking conversation.
It has. I really enjoyed it.
And to all our listeners out there, thanks for tuning in. We hope you found this exploration of AI and software development insightful, and we'll see you next time for another deep dive into the world of cutting-edge research.